Hello and a very warm welcome back to Maths Plus. Today we have an exponential problem. We have 8 to the power of x plus 125 to the power of x all over 20 to the power of x plus 50 to the power of x is equal to 19 over 10. So maybe give it a try and let me know how you get on. But if you're new to the channel, don't forget to subscribe and give it a thumbs up. I really appreciate that. So let's get started. Now in step 1 we are converting all the numbers to bases with exponents. So let's start out with the 8. We have 2 to the power of 3 is equal to 8, and we can use the power rule now and we can multiply out and we get 2 to the power of 3x. Now let's move on to the 125 to the power of x. We can write that again in a similar format. 5 to the power of 3 is 125 all to the power of x, and let's complete by multiplying with the power rule again and we get 5 to the power of 3x. Now let's work with the 20 to the power of x, and if we look at the number combinations we can get 4 by 5 is 20, which is 2 to the power of 2, and we also have a 5 there. That'll be a 5 to the power of 1 all to the power of x. Multiply in now and just reverse them and we get 5 to the power of x multiplied by 2 to the power of 2x. We're on to the 50 to the power of x now, and we can convert that to a 2 by a 25, which will be 2 to the power of 1 by 5 to the power of 2. Write in your 2 and let's encapsulate it with brackets to the power of x. Now we use the power rule and we'll get our final combination where we have 2 to the power of x multiplied by 5 to the power of 2x. That's awesome. Now we have all our bases with 2 and 5 converted to bases with exponents, and this will help us to go on to the next stage. So let's go on to step 2. Now in step 2 we can see that the numerator is a combination of 2 cubes. We can take out the 3, we can leave them in this format. So this means if we have the addition of 2 cubes, we have a formula. So we're going to do the sum of 2 cubes applied to the numerator. So let's get started here. So we're going to input our 2 to the power of x, replacing our a, and our 5 to the power of x, replacing the b. Now we're going to correspond with 2 to the power of x, all to be squared, for a squared minus 2 to the power of x multiplied by 5 to the power of x plus the second term squared, 5 to the power of x, all to be squared. Now we're turning our attention to step 3 and we're going to factor the denominator. So if we look below at the denominator, you can see we have common terms. We can extract 2 to the power of x from each term, and also we can extract 5 to the power of x, and we will get a factor of 2x inside plus 5 to the power of x. Alright, so that's the step 3 finalized, and we've factorized the numerator, taken out the common factor. Now we have this new combination with the cube on top and the factored terms below. So let's do a simplification now. You guessed it, we can factor out the 2 to the power of x plus 5 to the power of x above and below. Okay, and this simplifies our problem now into a more lighter fraction with less terms. So now we're going to separate out this, okay, into a set of fractions from the overall. Okay, so how are we going to do that? Well, first of all, we're going to bring in the 2's here, okay, because we're going to create combinations. So you can see here that if we apply the power rule, okay, we can bring in the 2 and separate it out then, because 2x is x plus x. And remember, we're going to have the addition of two bases with exponents, and it works out as 2 to the power of x by 2 to the power of x, 5 to the power of x by 5 to the power of x here. Alright, so now we're going to do some simplification. We're going to divide in each term by 2 to the power of x by 5 to the power of x from below. Now let's look at what we can work out here. So we can cancel the 2 to the power of x here and here. We can cancel the 5x here and here and the 2x. So that'll be a 1. And then over here the 5x's will cancel. Alright, so this gives us a new combination. And you can see here that we have the 2 and the 5 all to the power of x. And over here 5 and the 2. And that's upside down. So we're going to introduce now a substitution to simplify this. This will help us solve for x. So we're on to step 5 now. And we're going to, first of all, before we go and do any calculation, we'll set u equal to this term here. Okay, so this will work out neatly if we do that. So if we set u equal to 2 to the power of x over 5 to the power of x, we will get this combination, as we are going to have the inversion of the u is 1 over u, which is 5 to the power of x over 2 to the power of x. Now, what can we do here when we're going to solve? Well, if we have a denominator of u, well, we can multiply across the board to cancel that denominator. So let's multiply by u. So we get u by u is u squared, minus 1 by u is u. 1 over u multiplied by u is 1, as it's u over u. And over here, let's just place the u with the numerator, 19u over 10. Right, so let's simplify further and multiply across by 10. And we'll have 10u squared minus 10u plus 10 is equal to 19u. Now let's bring the 19 over, and we will have a quadratic on one side only. So we have minus 29 as the minus 10 and minus 19 will combine, and we'll have a plus 10. Now let's factorize this. So if we look at the factors, well, we can choose 5 and 2, because 5 by 2 will give us a 10. So we have 5u, okay, multiplied by 2u. And then let's do the reverse. Okay, it'll work out if we place a 5 here and a 2 here and a negative, and we will get the cross multiplier requirement. Right, so this means that u is equal to 2 over 5 when we set it to 0, or for the second factor, u is equal to 5 over 2. Now let's take two cases. So we're going to solve for u is equal to 2 over 5. So recall that u was substituted in, and it was 2 to the power of x over 5 to the power of x. And now let's compare over here. So let's assign our powers to the 2. So we know that 2 is 2 to the power of 1 and 5 is 2 to the power of 1. Now, as the bases are the same, let's compare the coefficients. We could also write this as 2 over 5 all to the power of x. And we can write this as 2 over 5 to the power of 1. So therefore, x is equal to 1. And for our counterpart, we'll have the inverse. So we can go 2 over 5 to the power of x, and we can state that that's equal to 5 over 2 to the power of 1. Let's invert it, and we can say that that's equal to 2 over 5 to the power of negative 1. Now we can compare coefficients, and again, we'll get a straightforward result. X is equal to negative 1. So there are the two answers, and our solutions are x is equal to 1 and x is equal to negative 1. So I hope you enjoyed the video. Thanks a lot for watching, and see you again soon on the next exciting maths video.